In this lesson, we'll be talking about how to draw the Lewis structure of covalent compounds, and specifically, we will be drawing carbon dioxide. Now, the first thing you do when you draw a Lewis structure of a covalent compound is you count up the number of valence electrons. In a bond, in a chemical bond, especially a covalent bond, you'll be using the valence electrons and not the kernel electrons. So let's count up how many we have. Carbon, if you look at its configuration, is going to be 2-4. That means that we have 4 valence electrons. Oxygen is going to have a configuration of 2-6, which means we'll have 6 valence electrons. And since we have CO2, we can add up the number we have, which is 4 from carbon, plus 6 for one oxygen, plus 6 for another, which means we have a total of 16 available electrons to use in our bonding. Now that's the first step, and we know we can use 16 valence electrons in our bond. The second step is going to be to pick a central atom. This is usually never hydrogen, and also you can usually tell because if there's carbon, it's going to be carbon, and if there's 1 of something and 4 of something else, for example, if 1 of something like carbon here and 2 oxygens, then your central compound or central atom is going to most likely be the one that is the least number of atoms. So here, since carbon likes to be the center of attention, let's draw carbon in the center. Okay, and since we have 2 oxygens, let's put those evenly around the carbon. You don't want to put them both on the same exact side. Typically when we draw these compounds, we're going to sort of draw them a little bit symmetrically if we can. So let's go ahead and put 1 oxygen on this side and 1 oxygen on this side. Okay, so we have 2 oxygens and a carbon, and the carbon is the central atom. Now, once we've drawn these, we have to create a sort of skeleton structure. Everything in this case has to be bonded. Now, what we're going to do is, since we know that there has to be a bond that exists between the carbon and each of the oxygens, at least a single bond, we're going to go ahead and draw a line between the carbon and the oxygens. Now that line, I'll draw this on the side here, the line is going to be the same thing as 2 valence electrons. 1 coming from the carbon and 1 coming from the oxygen that's bonded to the carbon. Okay? So that means that for each line there are 2 electrons. Now let's go ahead and let's draw in our remaining valence electrons. And if you take a look at oxygen, let's go up to number 2 again for a second. It has 1, 2, 3, 4, 5, 6 valence electrons. Same with this guy over here. And carbon has 4. Now we've used 2 of the electrons from carbon in covalent bonds, and we've used 1 electron from each oxygen in these covalent bonds, which means that we're left with, for carbon, 2 electrons, 2 valence electrons that are unbonded, and for oxygen, and let's actually draw these, we want to keep these in pairs, so let's draw that in a pair. So for carbon we have 2, and for oxygen we have 5, 3, 4, 5, 1, 2, 3, 4, 5. Now, you're either going to have these in pairs, in lone pairs, meaning like right here, for example, this is a lone pair, or you're going to have them in a bond. And if you see lone electrons, then you know that your valence structure is wrong. Okay? Another way you can look at this is that if I have less than an octet, or a duplet for hydrogen, 2 valence electrons, then my structure is also wrong. So let's count here. In oxygen, let's just take a look at this oxygen here. We have 1, 2, 3, 4, 5, and then 2 in the bond, so 6, 7. Okay? Now, that's not correct. We can't have only 7 valence electrons here. So what can we do to fix that? Well, let's think about this for a second. What can we do to make sure that this oxygen can have an octet, and that this oxygen can also have an octet here, because this one doesn't either? What can we do? If you're thinking that we can create another covalent bond for each of the oxygens, then you're thinking correctly. So what we'll do is we'll move 1 electron from the oxygen, and one electron from the carbon into the center here to create a bond. And we'll move one electron from this oxygen and one electron from this carbon here to create another bond. And what we'll end up with, our final structure, will be a carbon that's double bonded to two oxygens. Each of the oxygens is double bonded to the carbon. That leaves us with two lone pairs on the oxygens. 1, 2 on this side, and 1, 2 on this side. And that also leaves us with double bonds in the center here. Okay, so this checks out because we have the correct number of valence electrons. Okay, and we also have octets on everything. So our final structure is going to be carbon double bonded to two oxygens, and those oxygens are going to both have two lone pairs, giving us CO2.